Welcome, ladies and gentlemen. So what I'd like to do is show you how to write the equation of a parabola in vertex form as well as in standard form. Now, so the first thing we want to understand is, again, what exactly is vertex form and what's standard form? So vertex form is in the form of y equals a times x minus h squared plus k. And standard form is in the form y equals a times x squared plus bx plus c. So that's the two formulas that we're going to need. And all we're given is what exactly is the vertex and what the point. So to understand how to write, the equation of the parabola, we need to understand what information we're given. Now remember, when we're talking about a vertex, especially when we're discussing a vertex in vertex form, we represented our points of our vertex as h comma k. Hence, hence vertex form is you can identify the vertex. For any other point that's on the graph, those are going to we represent those as x and y. Even though the vertex is also on the graph, it is an x and y coordinate, it is a special point because it's either the maximum point or the minimum point based on the problem. So in this case, we have our vertex, which is specially denoted as h and k, and then any other point we have, we're going to be labeling as x and y. So you can see for all the problems that I'm going to do today in this video, we'll label them exactly the same. Now, since I'm given h and k and x and y, we're trying to write the equation of the line, so we want to plug that into either vertex form or to standard form. Well, for standard form, I have a, b, and c, and I also have x and y. So I could plug in the x and y, but then I would have nothing to do with my h and the k. So plugging my values into the vertex form is going to be ideal. So all I'm simply going to do is I have y equals a times x minus h squared plus k. I'm simply going to plug in 5 in for y. I don't have a value for a, times x, I'm going to plug in a negative 2, and then that's going to be minus a negative 4 squared, and then I'm going to add my k. So therefore, the only value that I still need to be able to find to be able to write my form write my equation in vertex form is going to be a. So I'm simply going to go ahead and simplify here. So I have 5 equals a. Now I'm going to do a little work here. Negative 2 minus a negative. Remember, that's going to turn to a double positive. Minus a negative is like the same thing as adding. So basically, I have negative 2 plus 4, which is going to be a positive 2. And positive 2 squared is just going to leave me with a 4 plus 1. Then I'll subtract 1 on both sides, and I'm left with 4 equals 4a. Divide by 4, a equals 1. So therefore, to write my equation, now I know what a is. Now, I'm not going to plug back in the h and the k, but I'm going to plug back in the h and the k because those are important values of my vertex form. But I'm going to leave x and y to represent a graph, an equation for any set of points. So therefore, my vertex form is going to be y equals 1 times x minus h. So instead of doing minus and negative, I'm just going to do x plus 4 squared plus 1. Now, obviously, we don't really need to write the 1 there, but I leave it there just to remind you, because for the other ones, we're going to have values of a when it's not 1. Now, to write this into standard form, basically what we need to do is expand this and then add the 1. So remember, x plus 4 squared is x plus 4 times x plus 4, and then plus 1. Now, you're going to have to apply FOIL here, or use the box method. And what you get is y equals, for this one, I'll multiply out. For the other ones, I'm going to do in my head. X squared plus 4x plus 4x plus 16 plus 1. Now, I combine like terms, and I simplify. So I have y equals x squared plus 8x plus 17. So therefore, ladies and gentlemen, that is your formula in standard form, and here is your equation in vertex form. All right? So now we're going to just do the same thing, but now I'm going to kind of speed it along because you kind of got, hopefully, at least the idea. We have my h and my k and my x and my y. So I'll still label them, though, because I know sometimes that can still be a little confusing. So that's h, that's k, that's x, and that's y. That's h, that's k, that's x, and that's y. All right, so let's go and plug them into my equation. And I'm just going to use a black for the whole one rather than using the color coding like I did here. So I have, let's see, negative 27 is equal to a times x minus h squared plus k, which is 0. All right, so now we'll just go again and go through the same steps. Basically, here I have 2 minus 5 is going to be a negative 3. Negative 3 squared is going to be a positive 9. So I have negative 27 equals 9a plus 0. So I always write the number in front of the a. Then I just divide by 9, and I get negative 3 equals a. Now, I plug that back into my equation. I'm going to rewrite that, though, with x's and y's. So it's x minus h, which is going to be 5, squared, plus k, which in this case is 0. So instead of saying plus 0, though, I will just leave that off. OK, so now, again, I basically need to go ahead and distribute my x minus 5. So please remember again, that is y equals negative 3 times x minus 5 times x minus 5. OK, so that's a binomial squared. So first of all, that's vertex form. So just to apply FOIL here, I get y equals negative 3. Now, when you have a multiplier, just multiply these out, and then just use parentheses here to multiply the negative 3 at the end. So what I have is x squared minus 10x plus 25. Then I now need to distribute this negative 3 to each and every one of these terms. So my final answer is going to be y equals negative 3x squared plus 30x minus 75. Ta-da! And that is your equation in standard form. All right, let's go and get to the last one here. So again, we're going to do the exact same method here. I'm just going to plug in my x and y, or plug in my points for x and y, and then also plug in my points for h and k. So I have negative 1 is equal to a times x, which is 2, minus k, which is going to be minus a negative 1, squared, plus a k, which would really be minus 4. So therefore, I have negative 1 equals a. Let's go ahead and simplify this. Again, we have a double negative. So 2 minus 1. 2 minus a negative 1 is the same thing as 2 plus 1, which would be 3. 3 squared is going to leave me with a 9 minus 4. Add the 4 to both sides. And I end up getting a 3 equals 9a. Divide by 9. Divide by 9. 1/3 equals a. A lot of fun stuff, right? OK, so now let's go ahead and write it into vertex form. So in vertex form here, I'm going to have y equals 1/3 times x minus h. X minus negative 1 is the same thing as x plus 1 squared minus 4. Now, again, I know there's a fraction here. But again, don't worry about it until the very, very end. Let's expand the x plus 1 squared. So rather than rewrite out there, I am just going to expand that because I know it's a perfect square trinomial. So I know that's going to be x squared plus 2x plus 1 minus 4. Then I need to distribute here my 1/3. So I get y equals 1/3 x squared plus 2/3 x plus 1/3 minus 4. Now, to combine the 1/3 and the negative 4, I got to rewrite this with the 4. Instead of having a denominator of 1, I got to have it as a denominator of 3. So I multiply by 3 over 3 to produce equivalent equations. And I get y equals 1/3 x squared plus 2/3 x. And therefore, that's going to be 4 times 3 is going to be negative 12. Negative 12 minus 1, or 1 minus 12 is going to be negative 11 over 3. So then that's going to give me a minus 11 over 3. And there you go, ladies and gentlemen. That is your standard form, and that is your vertex form. So there you go, ladies and gentlemen. That is how you write the equation of a parabola when given the vertex and a point. Thanks.